Hello fellow game developers and welcome to the third game challenge. Today we're going to be making an ASCII roguelike. A roguelike is basically just a top-down RPG. Usually it uses ASCII graphics, which we're going to use, and typically when you die in a roguelike, it's game over. So let's go ahead and look at what the graphics are going to look like. It's going to be just like this. We're just going to be basically printing out letters to the screen to represent walls or air for dots or air. Letters would be monsters, and then typically the @ sign is the player, but you can change this and do pretty much whatever you want. So we don't know graphics yet, so we can't really color the screen or anything like that. There are ways to color the command prompt. You can Google it, but you might as well just wait until we actually learn graphics. So let's take a look at some of the features we want to include. I'll probably be getting through at least these first four. I might include some of these as well, depending on how much time it takes. I haven't actually made this before, so we're going to all be kind of working on it for the first time together. It should be a learning experience for everybody. So number one, we're going to load the ASCII levels from a level file. So the reason we don't want to just hard code it into our game is because we want other people to be able to modify our levels or make their own levels without having to have our code. Not to mention we can change a level1.txt or whatever without recompiling our entire code. Number two, allow player movement using WSAD. The player should be able to move around really easily using just, the typical WSAD controls. Now there's a function I want to show you really quick called getcha that I haven't taught you yet. You have to include conio.h at the top of your screen, and this will give you the function. So say we want to get a char input from the user. We want to see like if he's typed WSA or D. So let's go ahead and do a while loop that's just going to loop forever. And it's going to get input from the user and print it to the screen. So if we use the getcha function, what that does is it grabs whatever we type from the screen without us having to press enter. So we can say input equals getcha. Now if you're on Visual Studio, you have to do an underscore in front or it's probably going to give you an error. Try it both ways. It just really depends on what version of C++ you're using, I think. If neither of those work, you may have to Google for a solution or just use standard, CN or something like that. But getcha is really cool. Let's actually see out the input. So you entered and then input, if I can spell right, and then endel. So let's see what this does exactly. So I'm going to run it. And let's zoom in. Now when I press keys, you'll notice it just immediately grabs them and puts them in our character, and then it outs them to the screen. So this is a really, really fast way to get input, and it's going to be really useful for our game. And also, we can do another cool trick. If we want to refresh the screen, delete everything in the command prompt, there's ways to do that, but there's a hacky way to do it that's really easy. We just make a string, so we could say string clear screen string or something, and we initialize it to 100 new lines or just a whole bunch of new line characters like that. And then all we do is see out this to the screen anytime we enter something. So see out clear screen string like that. So now whenever we run it, whenever we type input in, it's going to go all the way here to the bottom and it's going to give us an empty screen. Now this white stuff, I don't really know what that's about. I think there's something wrong with my command prompt. I blame Windows 8, but you probably won't have that. If you do have it, don't worry. As long as you're printing stuff out, this shouldn't happen, and you can fix it by moving that. I honestly don't know what that's about. It's kind of annoying. But alright, so that's how you clear the screen. I would definitely use this. And also another quick tip, if you don't want to create a string variable specifically for this, you can actually just get rid of the variable name like this and just call the constructor with the string and just put it right in your cout statement. And what that's going to do is it's going to create a string and use it and then just immediately throw it away. We're basically saying we don't care about holding on to this variable. I just want to get a string that does this, that has 100 new lines, and then you can just, get rid of it. Who cares? So we don't even give it a name. We just say string and then the constructor that initializes it to 100 new lines and print that out, and that'll work too. So let's go ahead and delete this and go back to our page. Man, I'm going to be doing a lot of talking here in this episode, I can already tell. Okay, so number 3, have some enemies that randomly move around and allow the player to attack them. So we want to actually have enemies, so it's kind of interesting. We could just give them really stupid AI that makes them just walk in random directions and bump into walls. And we could also make it so that they check to see if the player is standing right next to him, and if he is, then they attack the player or something like that. Number 4, make sure the player can't walk through walls. That's pretty self-explanatory. Just don't let him walk through the walls. Okay, so the optional objectives, I'm probably going to be doing number 7, but Number 5, make it so you can save the game and load it. So this is another application of stream and if stream. We just want to save the state of the player and the board, like save where all the monsters are, save the player's experience points and his health and things like that, and then load it next time we play the game so that you don't have to play the whole game in one sitting. Number 6, add items and money to the game. I probably won't do this, but who knows, maybe we'll do this. We've actually made an item shop before, so we could use that item shop code to actually add like an in-game shop somewhere, like a special letter like an S or a dollar sign or something, and whenever you walk up to that letter, you can purchase things. Number 7, allow the player to level up when he gets experience. Pretty simple, just once he has a certain amount of experience points, increase his level. Number 8, have multiple levels. So have like level 1, level 2, you know, not just one level, but make it to where you can reach the end of the level and go to the next one. That would also be pretty cool. You can use the hash for walls, dot for air, @ sign for players, and letters for monsters, or you can do whatever you want. It's your freaking game. Just make it how you want to make it. So you can go ahead and pause the video and get started if you feel pretty confident about this. Otherwise, you can stick around and I will show you some hints. So here's the hints. You can pause the video now or just keep watching. Okay, so if you're still watching or if you unpaused the video, you need some help. You don't know really where to get started. So the first hint is store your game level in a vector of strings. Each string is a row in your level, and you can treat this vector of strings as a 2D array. For instance, we have a vector string level data. This is going to hold our level. It's going to be like a 2D array because the vector part is going to be the y dimension and the string part is going to be the x dimension. Remember, strings are basically vectors. They're just specifically a vector of characters. So if we wanted to get, for instance, what object is at the coordinates x is 3 and y is 3, we would just say char object equals level data 3 3. And then if we wanted to set it, we could say level data 3 3 equals something. And that's how we're going to actually modify the data. Number 2, whenever your player or a monster wants to move in a direction, first check to see what char is on the board in that direction and use a switch statement to evaluate what should happen. So for instance, we could use a switch that checks if it's a wall, and if it's a wall, we say, no, you can't move there, and we don't move the player. If it's a dot, we do let him move, or if it's a monster, they initiate combat. Number 3, use an if stream and the getLine function to load your level from a .text file. Load one row at a time and put them in a string, then push back each string to your vector. So we're going to be using getLine to get each row of our level from our level file one at a time. It's pretty simple. We're just putting it in a string, and since we have a vector of strings, we can just call leveldata.pushback with that new string that we just read from the file. And we just do that until the file is empty, and then we have our level data and we can start playing. Number 4, surround your level with walls so that the player can't try to walk off the edge. Now you don't have to do this, but if you don't do this, you need to make sure you use some if statements to check the player's coordinates so he doesn't try to walk off the edge. If you try to access, for instance, level data -1 0 or something, like if you're trying to go too far left or too far up, then you're going to get what's called an access violation error, and it's probably going to crash your program. You never want to use like negative coordinates in here, and you never want to use coordinates that go beyond the size of this vector. So if this is only a 3 by 3 level, and you try to access the 4th element or something in one direction, then that's going to crash the game. You don't want to do that. So if you just surround your level with walls, that won't happen. That's just like a safe way to do it. Or you can use if statements. It's your choice. Number 5, create a monster class to store the monsters in a vector of monsters. Then each time you loop through the main game loop, you can loop through this monsters vector or array, you know, they're pretty much the same thing, and randomly move each one in a direction, or maybe not move him, maybe he picks his nose. You know, you can give him some simple AI with just using random chance. You can also check to see if the player is nearby and attack the player if he is. We want the monsters to actually fight back, so that's a good thing to do. We just check each direction and see if the player is there and fight him if he is. So I think that's all of the hints. So if this helped you out, if this helped you get started, go ahead and pause the video and try to implement it on your own. And if not, just stick around and I'll get started. Alright, if you unpause the video or if you're still here, then you are ready to see me give this a go, and hopefully I won't embarrass myself by not having a clue what I'm doing. So here is our main function. I already went ahead and made two classes. I made the game system class. Now this is going to be basically the class that handles all the game logic and kind of connects everything together, just so we don't have to put everything in main. That way we can use private variables and things, and it just makes things really easy. Right now there's no code in here. I just basically created the class and that's it. We also have a player class that I've created. Now the player does have some code. He's got a constructor, and the constructor just sets the position to 0, and position is X, Y, and Z, which it shouldn't be Z. This is a 2D game. I'm used to 3D, so let's go ahead and fix that. And we also have some getters and setters for the position. We have set position and get position. And I need to fix the definitions up here. We'll be making a 3D game pretty soon, don't worry. We also have an init function. Now this initializes the player. We just pass in variables that we want the player to have for his properties: level, health, attack, defense, and experience. And all it does is it takes those parameters and gives them to his private variables. So these are the player properties, and as you can see right here, this is where the properties are stored. They are private variables. Right now there's no getters and setters for this, so we'll probably have to create some of those later. And then the position, of course, is just integers. Now, let's go ahead and get started. So let's go to main.cpp. First thing we want to do is actually create an instance of our game system so we can start playing the game. So I'm going to make well, first we have to include game system. So let's include gamesystem.h. Now I'm going to make a game system. So we're going to say game system, like that. And now we need to make some kind of function in game system that plays the game. So let's make a function called void game, or let's say void play game, something like that. You could probably come up with a better name. So let's go ahead and put our function down here in the CPP file. Remember, we put our for declarations for all of our functions in the header file, and we put the actual implementation of the functions in the CPP file so that our header files aren't huge monolithic things that don't make sense. We want to be able to look at this header file and know what our game system does without having to see all the code that drives the game. So void play game, now we of course need to make sure it knows that it belongs to the game system class. So now we can call play game from our main class to get this thing started. Game system dot play game, and it's a function. So what should we give our game system? Let's give it some private variables, or a private variable for now. Let's give it a player. So we need to include player.h up here. Player.h, and this is going to be the player who's playing the game. So player, like that. Now we want the constructor of the game system to probably set up the player and get the game started, or perhaps we should make an init function. That really decides on what you want to do. I'm going to go ahead and just use the constructor because the constructor is getting called right here, and I'm happy with that. So the constructor sets up the game like that. So what we could actually do is pass in a string that's going to be the file name that we want to load the level for. So let's say string level file. I'm going to do just one level for now. So you can go above and beyond and make multiple levels. We probably won't get to that. So include, and we're going to include string, and using namespace std so that we can use a string here. So we're going to pass in string level file name like that, and put it right here. So now we need to be able to load a level, and we need a way to actually represent a level, right? The game system is just kind of the glue that holds everything together. It shouldn't do everything, because then the class is going to be too huge and complicated. So let's make another class called level. I'm going to go over here and add a class. So a class, add, and we're going to call it level. So we'll finish. We'll get rid of the destructor because we don't know what that is yet. Like that. Okay, and the level is going to contain the data for the level, and it's going to do things like allow the player to move around and the monsters to move around and things like that. So let's go ahead and have a private variable, and we're going to make our level data. Now, if you remember the hint, I said use a vector of strings. So we're going to do that. We're going to include vector, and we're going to include string using namespace std, and let's go ahead and include iostream just in case. Actually, we can do that in the CPP file. We don't have to do that here. So vector string level data. There we go. So here is our level data. Now when we first create a level, it's going to have no level data. Now we need to make a function that loads a level and initializes this level data to something. So let's write that function. So void load level, and we'll give it a file name. So we'll say string file name, like that. So let's go ahead and implement that like this. All right, so this is going to populate a level with data from a file. So what do we use to get input from a file? We use an if stream. So include if stream. And I'm getting a call, so give me just 1 second. And I'm back. Where was I? Okay, if stream, we are loading from a file. So before we actually load the level, let's actually just make a level file so that we can kind of know what we should be doing. So I'm going to open up, if you want to get to where your files get loaded from, just right click on your solution over here, or sorry, your project, and click open folder in File Explorer. So there's a bunch of crap here from all my other tutorials. Let's make a text document like this, and we're going to call it level1.text. And let's go ahead and edit with Notepad++. Highly recommend Notepad++. All right, so let's make our level. Now, the command prompt only lets you have 80 characters printed out to the screen. That's one of the constraints of the command prompt. I'm not sure what it is on Mac or Linux. So we gotta just try to make sure the level isn't bigger than that. So let's make a bunch of walls along the edge here at the top. And let's make a bunch of walls down the side like this. And let's fill that in with dots. So this is empty space, and then a wall at the end. So this looks big enough for now. I'm actually just going to copy this part and paste it a bunch of times like that. So this is starting out our little level file. You can already kind of tell that it's kind of starting to take shape already. And we'll copy this and put it on the bottom. Remember, we want to surround our level in walls. Okay, now we need to, let's create a little room for the player to start in, like this. The player will start in this room, and we'll put an @ sign right there in the top left corner, and that'll be our player. And for now, let's just do this. This is good enough. This will give us something to play around with. So we want to load this to the game, and then have our player walk around in it and bump into walls for now. So I'm going to go ahead and save that. Make sure you save it, you won't be able to load it. And we want to load it. So in the main.cpp file, since we gave game system a constructor, we got to pass in the name of the file. So we're going to say level1.text like that. And then game system is going to create a level. So we need an instance of a level, and here's game system.h. Let's make a new private variable, level like that. So include level needs to happen at the top here so we can get the level file, or the level class, level.h. Okay, so now we have a level, and let's load the level in the constructor. So level.load level. It's kind of redundant. We could have just called it load. Let's do that. I don't like load level. And we're going to load level file name like that. So I'm going to copy this and fix the name because it bugs me a little bit. There we go. So now it's called load instead of load level. All right, so let's actually load the level and populate our level data with it. So we need to create an if stream. So why is that giving us an error? Cannot open, oh, because it's f stream. F stream contains both if stream and upstream. So we're going to create an if stream in here. If stream file, and let's open file name. So file.open file name, and now we always should check to make sure it opens. So if file.fail like that, then we're going to see out error. No, actually we're going to use p-error. Remember I taught you p-error, and we'll say file name. Now whenever you're doing p-error with a string, it has to be a C string. So we have to say filename.cstr like that. Okay, so that will p-error, and I've actually not taught you this function, but we can quit the game by using something called exit. So we just say exit 1 or exit something. This is like saying return 0 in the main function. This will quit the whole game. Let's also throw a system pause in here. System pause, just for good measure. So it'll pause the game and then quit. There we go. So if we get to this point, then that means the file did open and we are ready for business. So let's go ahead and start reading in strings. So we're going to say string line, and we're going to read each line of this text file. So like this, left to right, we're going to read each line and put it in the string using the getLine function. So, and remember, we can use a while loop because getLine returns true if it can still read and false if it can't read any more text. So while getLine, and we're going to call getLine on the if stream, file on file, comma, and we're going to put the resulting line in our line string like that. So while this is successful, we're going to take this line and then we're going to put it in our level data. So this is a vector of strings where each element of the vector is one of these rows. So this is the 0th element, this is the first element, this is the second element. See how that works? So we just keep calling pushback with strings to add it to our level. So we're just going to say level data dot push back line, and that's going to add a line to our level data. Level data actually has an underscore. That's why that didn't work. All right, so there we go. This is a really simple function that loads the file. Now for good measure, I like to call file.close, which closes the file, but actually once you leave the function that you created the file in, it will close itself automatically, but it's just a good habit to be in. It doesn't hurt. All right, so now we're loading the level. So now let's print it out and make sure it worked. So let's make a print function. So void print level. So print actually is what it should be called since we're being redundant again. And let's go to our load function right below it and write our print function like that. And this belongs to level print. All right, so what's the best way to print this? Well, we could just use a cout, or we could use a printf. Let's use printf. So we have to loop through level data because we have to basically print out each string one at a time. So we're printing out the rows one at a time with an end L at the end or a new line at the end. So for int I equals 0, I is less than, and we can call level data dot size, and that'll be the number of rows. We'll just say I++, and then I'll use printf, and we're going to print a string, which is %s, and since we want to print out the string, it has to be a C string, because remember, printf uses only C strings, so we're going to say level data I, which is the ith string of level data, or the ith row, dot cstr, like that. Now the reason I'm using printf is because it's slightly faster than cout. It tends to perform better than cout, at least in all of my tests. All right, so that should print out the level. We should also do a new line after each string. And let's go ahead and do an extra new line at the bottom. So printf %s, or sorry, /n. All right, so now let's go ahead and load the level and print it out. We are already loading it in game system. So let's call level.print to test it. It's always good to do some tests, and then we'll do a system pause here. Pause. All right, let's run it and see what happens. What do you know? It worked first try. Good job, guys. We did it. All right, so here is our level. It's going to print this out each time we do input, and see we have our little player up here at the top left. Now we need to do some extra stuff. What we need to do is we need to process the board, right? Because we have the graphics of the board. We know, what it looks like, but we didn't set the position of the player or anything like that. We need to set the position of the player whenever we load it in. Now, I think the easiest way to do this is just after we load the level, we should just process the level by looping through the entire thing, and whenever we reach the @ sign, we know that's the player, so we can set up the player with that. If we ever reach a letter, then we know that's a monster, so we can add a monster to our monster list or something like that. All right, so that prints the level. Let's do one more thing for the level printing that should help us. Let's go ahead and do that trick where we see out a bunch of new lines. So we'll do cout string, and we're going to say /n, sorry, 100/n. So that should print out 100 new lines. And let's do that just to clear the screen. And cout is undefined because I don't have IOStream. Include IOStream. And let's also include cstdio, because I think typically this needs printf needs cstdio, but yeah, I could be wrong. I think on Visual Studio sometimes it just works anyways. Visual Studio is weird, but all right, so that's gonna work. That should print out a bunch of new lines. And we were doing something. Yes, we need to process the board now. So what we should do is, I guess, just process it in level, and we should have the level file populate some properties about the game system. So what we'll do is we'll pass in, for instance, the player as a reference parameter, and the level will set the player's properties and get everything set up. So let's go ahead and make a function for that. So we need to include player.h up here, player.h, so that we can have a player. And we're going to say void process. Actually, we could just do this in load. Why don't we just do it in load? That makes more sense. So we're going to load with file name. Let's also pass in a reference parameter for the player. So player ampersand player, because that's a reference parameter, so we can change it. And we're also going to pass in some other stuff like a list of monsters, but for now this should be good. So let's go ahead and add that to our level load function. Okay, so this part loads the level, process the level right here. So down here we're going to loop through the entire level. So for int I equals 0, I is less than level data dot size I plus plus. Now remember, strings are basically the same thing as vectors, so underscore level data. So we can do another for loop, int j equals 0. J is less than the current string, so level data I dot size j plus plus. So what happens here is the I loop loops through each row, and the j loop loops through each letter in that row. So the j loop is going to go like 1, 2, 3 like this, and the I loop is going to go 1, 2, 3 like this. So this should loop through everything in our two-dimensional little vector thing. So now we're processing this. So let's say char tile, and we're going to say tile equals level data I j. So this is going to get the current tile that we are looking at in our level. So now what we should do is process this tile, and let's use a switch statement. So switch tile, because that's perfect for what we're doing. Switch tile, and we'll say case, and let's say case at for a player break. And I'm not sure if I taught you this yet. I always forget to teach you certain things. But there's also another thing we can have called default. But we don't need that. So I'm not going to teach you default. But basically default, actually I will teach you default. If you put default, this is like having else at the end of your switch. So if we put like a cout statement here, it would be like unrecognized symbol because we didn't process it or something. But we're not going to go ahead and do that, because right now all we care about is the player. We don't really care about processing the walls, because we can do that later when the player's trying to move around. He can check to see if there's a wall in his way. So case at, that means this is the player. So what we should do is say player dot set position, and we're going to set his position to the current position on the board, which happens to be the x coordinate is j and the y coordinate is I, because I is rows and j is columns. So we're just going to set his position to j comma I for x, y, because set position takes two parameters. As you can see right here, if I zoom in, it takes x and y. Alright, so that will set the player's position. Oh no. Oh no. That will set the player's position, and that's pretty much all we want this to do for now, but we can also do some cases in the future that handle new monsters and things like that. So that's it for this for now. That should loop through everything, get our player's properties and set them. So let's go to game system and make sure we're doing that. And we are not. So before we do that, let's go ahead and initialize the player. So player dot init, and we're going to say he's level 1, he has 100 health, he has 10 attack, whatever that means, 10 defense, and he has 0 experience. Okay, I don't know what these things mean yet. We haven't figured that out yet. But that's his initial properties. And now we'll pass in the player to the load to get his position on the board, because his position on the board is determined by where this at is. Alright, so now we have the player's information all set up. We have the level all set up. Now let's do some stuff in play game. Let's actually let the player move around. So let's go ahead and make a flag, a sentinel, a bool is done equals false. And we're going to say while is done is equal to true. No, sorry. While is done is not equal to true. There we go. Or is done is equal to false. Whatever you want to do, it doesn't matter. Alright, so this is going to be our game loop. Remember, we always have a game loop. This is going to let us keep playing the level over and over and over. So let's start. Let's go ahead and get rid of this right here. Let's start by printing out the level. So we're going to say level.print, and then let's cout enter a move command or something like that. Cout enter a move command, and we'll say WSAD, something like that, even though this is probably pretty self-explanatory. Alright, enter a move command, and cout is not defined because we didn't include IOStream. Include IOStream. You'll notice I use cout and printf. So let's go ahead and use printf. It's okay to mix them, it doesn't really matter. Alright, so printf, enter a move command, and now we're going to use that handy getcha to actually get the input from the player. So what we probably should do is make this a file, or make this a function that gets the player input. So let's do that. So void player move, like that. So player move will do the input for the player. And we'll put that right down here. And it belongs to game system. And we'll copy this part down here. And let's go ahead and call player move. Like that. Alright, so enter a move command. So let's make char input, and input equals getcha. And we have to include conio.h in order to get that. So include conio.h. There we go. So input equals getcha. Here we go. And now we can process that input. So we'll say switch, and actually we are going to get to use the default. So switch input case W. And let's actually make case W and case capital W do the same thing. Case W. Remember, we can do that just like this because the case will, if you type in a lowercase w, it'll just keep going since we don't have a break function in there. You have to put, or not a break function, a break statement. You have to put a break here. If you don't, then it'll keep going whenever we land there. And that's actually what we want in this case. So if that happens, then we're going to move the player up. So let's wait on that. Case S and case capital S. Visual Studio keeps trying to auto format for me. I'm just going to copy paste this to make it faster. So WSAD. So we're going to say up, down, left, right, like that. And then finally default, and we're going to say break cout. Printf, invalid input. There we go. And then we can do a system pause. All right. So now depending on what he types in here is going to determine how the player moves. So if he types in a W, we want to try to move him up. So what we should do is check the level and see if the player can move up. So this is something we could either do in the level or do in the game system, and I think we should actually do it in the level. Let's keep the game system really small. So let's make a new function in level, and we're going to say void try move player, like this. And this will try to move the player, or we could just call it move player, and sometimes it'll fail, depending on if there's a wall in the way, essentially. So let's put that down here, move player, and level, like that. And what we can do is, instead of actually processing the switch here in game system, we can just pass the input letter on to player.move and let it take care of it. So let's do that. That's actually probably the easier way to do it. So I'm going to copy this and delete it. And instead I'm just going to call underscore level dot move player. And we're going to pass in the input, and we also should pass in the player as well. So let's pass in player, like that, because it needs to move the player. All right, and then in level, we're going to copy paste this here, and move player needs char input and player ampersand player, because we want to make it a reference parameter. So I'm going to copy this and fix our definition up here. Okay, so now move player takes care of the switch that does the processing, and here's where we can check if the player can move up. So we have the player's coordinates, because we can get the player's coordinates with player.getPosition, I believe. So let's go ahead and do that up here. Int player x equals player. Actually, no, the function works like this. We just say int player x, int player y. And if we go to player.h, you'll see we just pass in the reference parameters x and y to get position, and get position just sets them equal to it. And since it's reference parameters, it will modify the actual variable that we pass in. So we're just going to call, where are we? Level, that's where we are. So we're just going to call player dot get position with player x, player y. So that will get his position. There we go. And since we put walls all the way around, we know he's not going to be standing inside a wall. And that helps us out a little bit. Okay, so now we need to check what character is at a given board position and get that back. So to make it simple, let's just write a function that gets the character at a certain spot. And it's actually going to be a really simple function, so we may not even need the function, but it helps us in case we want to do some extra processing on it later. So we're going to say char get object, get tile at int x, int y, like that. So this will just return the tile at that certain spot, which, since we're just using a 2D vector, and this is level, it's as simple as char tile equals, and it's going to be level data y and then x, because remember, y comes first because y is your rows and x is your columns. So char tile equals that, and then we return tile. And to make this even smaller, we can just get rid of the intermediate variable and just return the character level data xy itself, just to make this function super duper small. Now this is pretty simple. We wouldn't normally need a function for this, but this kind of abstracts it and makes it super simple to understand. So we're going to say, let's say char move tile. So in this case, move tile equals get tile. And since the player is going up, it's going to be player x and then player y. And we're going to say, we have to say that up is actually negative y and down is positive y. Because whenever we loop through here and as y gets bigger, we actually go down. So we're kind of reversing what you would normally think of as y is up or positive y is up and negative y is down. Instead, it's positive y is down and negative y is up. And you could fix that if you wanted, but it's pretty simple to just think of it that way. A lot of graphic systems actually work like that, where positive y goes down. So since we're moving up, that's player y minus 1. So that's the tile right above him. Now, what we need to do is process this move tile and see if we can actually move there. So what we need to do is make another function like can move, or we can actually make a function that returns a specific code based on what happened. Because if it's a monster, they should do battle or something like that. So let's go ahead and, so this is move player. We'll say, actually I guess we could just process it in here. It's not going to be too complicated. I just don't like having nested switch statements. I don't like to have a switch statement inside of a switch statement. I would much rather just have another function. So while I'm thinking about it, let's just do the other directions. So down is going to be +1. Left is going to be the same y coordinate, but the x coordinate is going to be -1. And then the right direction is going to be the x coordinate +1. So that'll get the tile we are trying to move to. So let's go ahead and just make another switch, I guess, inside. So switch, we might pretty this up when I realize a better way to do this. So switch move tile, like that. And just like anything, we can nest switch statements inside of each other. So I'm going to give a little spacing here so it's a little easier to read. So switch move tile, we're going to say case, and if it's a wall, we're not going to let the player move. So we'll say printf, you ran into a wall. And then I guess we can do a system pause, just so they have time to read it. So /n and system pause, like that. And break. And case dot, which is going to be the ground, then we let him move. So what we're going to do is just move the player in that direction. So we're going to say player dot set position, and we're going to set his position to this up here, which is just the new coordinate. So we just copy paste that, and that'll set his position up 1. But now we also need to change our level data, because now, for instance, say this @ sign moves down. We changed the position of the player, but we didn't change the @ sign to a dot. So what we need to do is change the @ sign to a dot, and then change this dot to an @ sign, like that, right? So let's go ahead and do that. So player.setPosition, and he's gonna, okay, that's gonna set his position. So we're gonna say we need to make a set tile function so we can actually set the tiles. So void set tile. Let's go ahead and say getters, setters. So void set tile int x, int y, char tile. Like that. So we're going to set the tile at xy to the new tile. All right. Level set tile. And it's going to be as simple as level data y x equals tile. Like that. So now it's really simple. We just call set tile, and the current player position, which is player x, player y, is going to become a dot, right? So that's going to be, we don't need to comment that. I'll comment it later. You can get the pastebin version in the description later and see all the helpful comments that I put in. And then we're going to call set tile player y minus 1 to the player symbol, which is @ like that. And this is going to move the player. So this is a pretty small switch, but we probably should definitely put this in a function. Definitely want to put this in a function. So let's call the function, well, this is called move player. So process player move. I guess that sounds okay. That sounds fine to me. And we can make that a private function since we're never going to use that outside. And actually we can make get tile and set tile private functions too, because I don't think, actually, yeah, we probably should leave it like that just for now. So we're going to say private, and it's going to be void process player move. And the reason I'm making it a private function is because nobody else except the level ever needs to call this. So it's just a safe thing to do. So process player move is going to take the char. What is that going to take? It's going to take we should pass in the move tile, and we should pass in the player and then the player target coordinates. Okay, so that's what we'll do. So char, actually, we can just, oh, that's, okay. All right, we can just do all of this in the function. So all we're doing is passing in the player and then the target coordinates. That's what we're going to do. Okay. So sometimes it takes me a little bit to figure out what I should actually be doing. So process player move, it's going to be player, and then int new x, or target x, int target y, like that. So let's make it down here at the bottom. Void, and what did I call it? I have something copy pasted, so I don't want to process player move. That's going to be level colon process player move. This will process the move that we determine he should do based on the move player function. So we're going to pass in the player and then int target x, int target y. Just like that. And I'm going to paste that stuff I copied and delete it up here, like that. And what we're going to do, I don't need move tile anymore. What we're going to do is we're just going to call process player move with player, and we're going to pass in, for target x, we're going to pass in, or target x and target y, we're going to pass in this right here. So this is where he wants to move, and then his location about where he is still here. All right, so that's, look how much smaller this is. That looks much better. So this is player y plus 1, and this is player x minus 1, player x minus 1, and player x plus 1. That's so much better. There we go. All right, so this will process the move. So let's say char move tile equals that. Switch move tile, you ran into a wall. Now we need to get player x and player y again. So int player x, int player y. Player dot get position, player x, player y, like that. Pause the video if I'm going too fast. Now we're not going to do -1 here. We're actually going to say target x and target y, because the move tile is our target tile, so we use the target position to get it. And then down here, we're going to set target position, and we're going to set the player's position to the target position, because he moved to the target. And we're going to set the target position, so target y and target x, to the @ sign because he moved there. And we're going to set the old player position, which is stored in player x and player y, to a dot. And this is going to allow us to move around, and I think this is actually going to work. So should we try it? Dare we try? Is everything hooked up right? We call level.print player move. All right, so we have a chain of functions that's processing everything. So look how small our game system is. It's really easy to read, right? This is our game. This is how you want your code to be. You don't want a game system that has like 10,000 lines of code in it. You want to be able to kind of move some of the logic to other places. Like the level is going to handle most of the logic, like the player moving around and things like that. So let's go ahead and run it. All right, press any key to continue. I don't know why we had that. All right. Enter a move command. So let me zoom in so you can see what's going on. Here's our @ up here. I'm going to try to move to the right. And look, we moved to the right. Now I'm going to move down and right. Look, we can move around. Whee! And now let me try to bump into the wall. All right, I can't bump into the wall. Now it's kind of annoying to have this press any key to continue. So I don't think we should actually do that. Because see what happens is whenever I do that, it like moves the command prompt around. And again, these white bars here, I have no idea what that is. So I don't know. Maybe one of y'all can Google it and let me know what's going on with my command prompt. All right, so yeah, let's definitely fix that you ran into a wall thing because that's really, really obnoxious. Coming down to the level, where do we say you ran into a wall? Right here. Let's just, all we got to do is basically not let him move there. So we can just get rid of this. We don't need to check for a wall because the only time we're letting him move is when it's a dot. So since he can only move if it's a dot, then we can assume if it's anything else, then he can't move there. And we could change our file format to have different letters and things and do all sorts of really cool stuff if we wanted to. Okay, so that's movement. Now we need monsters, right? we're getting close. We're getting close to having our basic game. Now, what are all the challenges that I said? Load the levels, allow player movement, so that's check. We'll say check. Alright, that's load ASCII level, allow player movement, check. Have enemies. And we have check on number 4. So number 3, have enemies that randomly move around and allow the player to attack them. So that's what we need to do. Now we need to make an enemy class, or we'll actually make a monster class. All of my enemies are going to be called monsters. Or should they be called enemies? Let's call them enemies. That's a little bit more broad because it doesn't have to be a monster. So we're going to make a new class, add, nope, that's class wizard. That's not what I wanted. Or maybe it is. I don't know what a class wizard is. Make a new class, and we're going to make enemy. The enemy class. So let's get rid of the destructor, like that. Get rid of the destructor. And the enemy needs some properties, so let's give him some private variables. Private. We're going to say int attack, int, that's underscore attack, good programming practice, int defense, defense, int HP, or health, and int experience value, because they should be worth a certain amount of experience points. And let's go ahead and give it a level, just to have a number, I guess. It's pretty arbitrary, really, at least the way I'm going to do it. Alright, so level, attack, defense, health, experience. Now, if you were going above and beyond, you could also like have a vector of items, and it'd be like possible drops. So like there's a chance that it drops a certain item. You could even also have a vector of floating point numbers that gives you the percentages for each item of dropping and things like that. You could really go crazy with this. But for now, I'm just going to make it really simple because we want to keep these videos kind of short. You can really figure out all this other stuff on your own for sure. And of course, if you get stuck, ask me questions in the description. Do not be afraid, not in the description, in the comments. Do not be afraid to ask me questions. All right, so enemy. We have our enemy class. Let's go ahead and should we make the constructor initialize the enemy? Yeah, let's go ahead and actually, let's just see how we're going to use him first. So let's go to game system, and game system is going to hold all the enemies. So include enemy, enemy.h. Okay, so we're going to say vector enemy enemies. Underscore enemies. Now you'll also notice none of my other classes are including game system. That's a good thing. We don't want them to include game system. They don't need to know about game system. They just need to know how to do their own business and know how to use the things that we pass into them. They don't need to call any game system functions. We have encapsulated a bunch of functionality in game system, and that's a really good programming practice. It keeps your code nice and clean, and it keeps things called circular includes from happening as well. Like we don't want two classes to be too dependent on each other. We want this to basically encapsulate all of our game logic, but we don't want to make it do all of the work. So that's why we have level doing a lot of the work and things like that. All right, so vector enemies. Let's make some enemies. Now we need to figure out what kinds of enemies we can have, and let's actually make our level a little more interesting. Let's make some more ampersands, or sorry, pound signs. Let's make some walls here. Yeah, like that, and we'll have a dot here. Let's see, I don't want to spend forever on this. Okay, we'll make a room here. Let's make like some corridors. So like this, or something like that. Alright, so we got a basic corridor kind of thing going on here. That looks pretty cool. And let's see. Let's do that. This dungeon is so dumb. Okay, let's make this a dead end. Haha. And this is a room. Now you could also add like doors to the game and chests and all sorts of really cool things just using different ASCII characters. You can really go nuts with this stuff and make the game as complicated as you want. You know how to use if statements and conditional logic to make interesting things happen. So you might as well, you know, just make some cool stuff, like experiment. You can do anything you want. This is your game. You can totally go completely nuts with all these features, and that is a really good thing. It's going to make you a better programmer because you're going to be thinking out these problems on your own and thinking, how can I make this better? How can I make this more interesting and more fun? How can I improve the AI? Or how can I make it so that there's an item shop that's really interesting? Okay, let's add a lot of stuff in here. I'm just going to add like a thick wall or something because I'm getting lazy and I don't want to add a whole bunch of other stuff. Yeah, let's do that. And then maybe a shortcut like that. And then, sure. This is good enough. All right, so here's our basic, pretty crappy level. I'm not going to make any more levels because this takes too long. You can definitely do that on your own. 2 more. Let's make it symmetrical. 1, 2, 3, 4. All right, we got rooms. All right, let's make some monsters. So we're going to say capital S is snake. Let's make some goblins in here. We'll say lowercase g is goblin. Like 4 goblins in there. Let's make, what else? We'll put a freaking dragon down here at the bottom right, and that's just going to destroy the player. Let's put it way bottom right so it doesn't wander too far through the level. So we got a bunch of goblins. Let's make B for bandit. O for ogre. And let's just make like a few more goblins and a snake or 2. There. Alright, so we got a few monsters. Let's go ahead and... oh, that reminds me. So our enemy class needs to, we need to be able to tell what kind of enemy this is. So we're going to say string name, so we can, print stuff to the screen. Underscore name. So we could, name it goblin. And we also need to say char tile. So this is going to be its tile representation. So for a snake, tile is going to be capital S. For a goblin, tile is going to be lowercase g. So, all right, let's worry about loading in the monsters. Okay, and load level is, where is load level? Here's load level. All right, so this is going to load. So we already have our switch statement set up to process stuff. So all we got to do is add some more case statements in here that process all the monsters. And what we're going to do is modify our enemies vector using the load level function. So what we need to do is pass this in as a reference parameter. And yes, you can pass vectors in as reference parameters. In fact, it's always a good idea to pass a vector as a reference parameter in every case. If you don't want the vector to be modified, you should just use the const keyword in front. Because if you don't pass a vector in by reference, if you pass it in by value, it's going to copy every single element. So if you have like 1,000,000 elements, it has to do literally 1,000,000 copies. It sucks. So just always do reference, and if you don't want it to change, make it constant. But we do want it to change. So let's copy this definition, and we're going to, level.h. We're going to go here at the end of load and also pass in vector enemies. I'm going to get rid of the underscore because that's not a private variable anymore, and we're going to pass it in like that. So we're going to change also the definition as well as the declaration. There we go. All right, so now all we do is, oh, that's right, we have to include enemy. So up here we're going to say include enemy.h. All right, that will include our enemies. And where were we? We need to pass in this vector now. So that's in game system, isn't it? Yes, load. And then we're going to say comma enemies. So that'll pass in our enemies vector. Wonderful. And level will now populate the enemies vector. Now, if we wanted to, honestly, we could have probably stored these in the level, but I kind of like doing it this way. It kind of separates the data from the level, and the level just becomes sort of a class that processes the data, but you can, of course, do it however you want. We could argue all day about the best way to do this. So, all right, we got it passing in. Now we need to process these things. So case S, that is snake, and this is player. All right. So if it's a snake, we need to create a new object that's a snake object and add it to our enemies class. Or sorry, it's an enemy object, but it has information about a snake. So remember what I said about making a new or adding a new object to a vector. Actually, I don't know if I've actually. It has to do. All right. Let me start over here for a second. First of all, what we need to do is create a new enemy. So enemy, new enemy, like this. Now the problem is, whenever you create variables in a case statement, it's typically going to give you an error. So you have to actually create your variable out here. But instead, what we can do is, if we don't want to hold on to the variable name, instead we can just use that constructor trick that we did with print level, where we just use the constructor. So it's just going to use the variable in this one line of code and then get rid of it. So what we can do is call enemies.pushback, and then we can call enemy. This is going to make a new enemy, and then in here we'll make the constructor actually build the enemy for us. Now doing it this way works, or perhaps actually probably a better way is to just have actually let's just do it this way. This way is fine. Alright, so this is going to build our snake enemy. I can never decide the best way I want to do these things. Now what we need to do is make the snake constructor do things. Now I hope this doesn't confuse you. Remember, it's like creating an enemy up here and passing it in. But instead we can do it all in one line, and we don't need to hold on to the intermediate variable, because all we're trying to do is add a new enemy to this. We don't care what the variable name is or anything like that. So let's go to enemy.h, and let's say string name. We're going to say char tile, int level, int attack, int defense, int health, int xp. Sure. Alright, so we're going to copy this down to the constructor here, and that's a long definition. Alright, so name equals name, tile equals tile, and level equals level, and attack equals attack, defense equals defense, health equals health, and almost done. Experience value equals XP. There we go. So that's going to construct him. And we're getting an error because we need to include string. Include string. String. There we go. So now we can, in the level.cpp, we can push all our properties back here. So first comes the name. So snake, comma, the tile is, we can actually just pass in tile here, because that is the tile. The level, we're going to say is level 1, snakes suck. The attack is, I don't know, 5, now 3. The defense is like 2, 1. The health is 10, and the XP is, he's worth 10 XP. I don't know. I'm not balancing this, so it's probably not going to play very well. We'll just make our player really OP so he doesn't die immediately. Alright, so that's the snake. What else do we have? Goblin. So case G break, and we'll push back a goblin to the enemies. And the goblin is called goblin, and he is level 2. His attack is 10. His defense is 5, and his health is 40, 35, and his XP value is 50. Sure. All right. All right. Case capital O, I believe, is an ogre. Let's see. Capital O is ogre. Yes. So we're gonna push back. Let's say ogre. And let's say his level is 4, his attack is 20, defense is 20, health is 200, so he's tough, XP value 500, super powerful. Alright, and then case D, we're just going to die once we get to D. So case D, dragon, is that the last thing we have? Oh, B is bandit, let's put like 2 bandits. We don't just want 1. Alright, dragon is going to be level 100. Attack 2000, defense 2000, health 2000, and experience really big. You will never defeat him though. And then case bandit. Bandit, like that. Bandit's going to be level 3. He's going to have 15 attack, 10 defense, 100 health, and he's going to be worth, we'll say 250 experience. Pretty arbitrary stuff. All right, so this is going to create a vector of enemies, and it's going to be all the enemies in the game. So now we actually need to do stuff with these enemies. Now, whenever a player goes to a tile, we need to check if it's an enemy, and if it is, what we're going to do is loop through our entire enemy list, because we don't know about other good ways to do lookups with tables. We're going to loop through our entire enemy list and check each enemy's coordinates and see if the coordinates are that of the enemy, and if they are, then we're going to say, okay, you're running into this enemy, so you're going to battle him. So let's do that. And here's process player move. So let's go ahead and process a wall, and what we're going to do is just call break. So we're going to process a wall and then break, and we're going to say default. So anything that's not a wall, because remember, default is like the else. Anything that's not a dot and not a wall, that's going to be a monster. Really simple. So we're just going to do battle with that monster. So we're going to say, we're going to make a new function called battle monster. Let's see. We'll make it a private function. Shall we? Shall we make it a private function? For now. Void battle monster. We're going to say player, and int target x, int target y. So that's going to battle the monster at this target position. So we'll copy that right here. Good. That's what we want. All right, so we're going to call battle monster with player, target x, target y. Awesome. Now here's where we're going to do a battle between the player and the monster. So what we need to do is first figure out which monster the player is battling. We know there is a monster there because we hit one of those letters. So let's go ahead and just loop through the entire monster array. Now, here's where we have an issue. We don't have the array of monsters. The array of monsters is actually, the array of enemies actually exists in gamesystem.h. And honestly, I think that we should probably just give the level this vector of enemies and just let the level take care of that, because the game system doesn't really need that vector of enemies. And we probably could have done the same thing with the player, but I think this is fine. So let's go ahead and get rid of it here. Get rid of the vector there, and we don't need to include enemy.h anymore. And instead, we're just going to have also a vector of enemies, like that. So where we passed it in, we don't need to do that anymore. We don't need to pass it into load. Instead, what we're going to do is just use our local enemies variable, our private enemies variable. String is undefined. Yes. Include string. This is an enemy.h using namespace std. Forgot to do that. Okay, so level.cpp. Load no longer takes that. Instead, down here, we're just going to use underscore enemies because now it's a local variable for our level, like that. Okay, there we go. So game system is going to call, there we go. Their level is going to call battle monster. So level battle monster. And what we need to do is loop through all the monsters. So for int I equals 0, I is less than enemies. I keep calling them monsters. Enemies.size, I++. If target x is equal to enemies I dot, and we need to say get x, or we should just do a get position again. So int enemy x, int enemy y. And we'll just copy the get position from the player for the enemy. And actually, we never did add position variables for the enemy, so that's another thing we need to do. So we'll copy paste the position variables, and we're also going to copy paste set position and get position to the enemy, like this. And we're going to do the same thing. We're going to copy set position and get position from the player right here. Pretty simple. and put it in enemy, except we need to change the word player to enemy. And enemy, there we go. So now we can actually use that. And this is in gamesystem.cpp. We no longer need to pass in enemies because level's taking care of its own array of enemies. Alright, so back to level.cpp. So enemy I, we're just going to say enemies I.get position underscore enemies I.get position. And we're going to get enemy X and enemy Y. So we're going to pass in the reference variables enemy X and enemy Y, and enemies is going to fill those with his position, or the current enemy, because we're looping through all of the enemies that we have. So if target X is equal to enemy X and target Y is equal to enemy Y, then this is the enemy we want to battle. So in that case, battle, right? Because this is the enemy. And then after that, we're going to return from the function. This will quit the function because we don't need to check any more enemies because we know this is the enemy. All right, so now what we're going to do is call, let's see, we're going to call a function in player to get his attack roll. So let's go ahead and do that. Let's make a function. So we're going to make it return an integer, int attack, and it's going to just compute his random attack chance based on his attack variable. So let's go ahead and do that. So we're going to come down here to the player.cpp file, int attack, and that's going to, we need a default random number generator, or we need a random number generator, so include random. So we need default rand engine, and I'm going to make a static default rand engine, and we actually need using namespace std. I don't think we did that. No, we didn't do that. Using namespace std. So we have a default rand engine, random engine. Is that what it's called? Default random engine. There we go. Static default random engine. And we're going to seed this with time, so we need to include cTime, and we're going to say seed it with time null, like that. That's how you seed your random number generator with time. And since it's static, we're only going to generate this one time. We're only going to seed it one time, and then anytime we call attack, it'll use the same random generator. And let's make a uniform int distribution, and we're going to say it's going to be a random number between 0 and his attack. So attack, like that. Oh, and we actually have to call it attack chance, or attack roll, like that. That should work. Ah, it's a template, so we have to say int. That's right, I always forget how these work. All right, so that will create our attack roll thing, and is attack not actually, yes it is, attack. Oh, the reason it's saying attack is undefined is because I didn't say that attack function belongs to player. All right, so here is our roll. Now what we're going to do is just return the roll. So we're just going to say return attack roll random engine. So this is going to do an attack roll and return it. And let's copy paste this and do the same thing for an enemy. So the enemy is also going to have an attack roll. So enemy attack, and let's put that up here. It's going to be int attack, like that. Okay, so that will return an enemy attack. So let's go ahead and use that. So what's going to happen is first the player is going to attack. So we're going to say, we're going to make an integer up here, int attack roll. We're going to say first the player attacks because he moved first. So attack roll equals player dot attack, and that's going to return his attack roll. And then what we need to do is make a function in the monster that damages him. So in enemy.h, we're going to say void or say we'll say bool because we can make it return true if he died and false if he didn't die. So bool take damage, and we're going to say int attack. All right, so let's go ahead and do that. Let's go down here to, and let's actually make bool take damage. Let's make it an integer take damage. And what we can do is return 0 if he didn't die. And if we return any other number, that's going to mean he died. And the number we return is the experience value. So we're going to return the number of experience points that the player gets. All right, so int, and it's going to be enemy take damage. Int enemy take damage. And I think the way we should do it is we should say, we have to include all our stuff in enemy. We have to include random and include ctime. And do we have using namespace std? Yes, we do. So everything else should work. There we go. So take damage. What this is going to do is it's going to say, let's take the defense of the monster and subtract that from the attack. So we'll say attack minus equals defense. So if attack after that is still greater than 0, so let's say we attack the monster and our attack is 10 and its defense is 20, we can't do any damage. Now there's probably a much better way you should do this, but that's how I'm going to do it. So if attack is greater than 0, now we can damage. Else, we're just going to return 0 because obviously he didn't die. Like that. Or we can just put return 0 at the bottom. So if anything, if he doesn't die, at the end we'll return 0. So if attack is greater than 0, we're going to say health minus equals attack. Now we need to check if he died. So check if he died, and this is check if the attack does damage. All right, so if he died, we're going to say, so to check that, we're going to say if health is less than or equal to 0. If his health is less than or equal to 0, that means he died. So if he died, we're going to just return experience value, like that. And that will tell us he's dead because this isn't 0, and the player should get this much experience. So let's go back to level.h, and we're going to say int attack result, like that. So let's say enemies I dot take damage, and it's going to be attack roll, like that. And we're going to get the return value and store it in attack result. So attack result equals enemies I dot take damage. Now if attack result is not equal to 0, meaning he died, then we're going to say player dot add experience with attack result, like that. That'll add experience. Now we haven't written that function, so let's write it really fast. So this is going to be just like almost like a little setter, so we can just do it up here. Void add experience, like that, and it should be int experience. And let's go ahead and implement it in our CPP file right below set position. Okay, now what we're going to do is say experience plus equals experience. And then what we should do is say, let's say each time you get 50 experience points, you level up. I know that's ridiculous, but that's what we're going to do. So we're going to say, why didn't this work? Oh, because we always forget to do that. Player. Always got to remember, this function belongs to player. So what we're going to do is say while experience is, or while underscore experience is greater than 50. So each time we are at 50 experience, we do a level up. First, we're going to subtract 50 experience. Hence, minus equals 50, because we just spent 50 experience points on a level. Then we're going to say attack plus equals 10, defense plus equals 5, and health plus equals 10, and level plus plus. Are there any other properties? No, that's good. All right, so that will do a level up. Level up. And we're going to say printf leveled up. There we go. So that'll print out we leveled up. And and just print to the screen. And each time we level up, I need a semicolon. Each time we level up, let's do a system pause so that we inform the player that he leveled up. System pause so he can actually see it. We don't want to use system pause too much. All right, so that will printf leveled up each time he levels up. And we should also probably print out some useful battle information, right? So we could say printf player attacked monster with a roll of %d, which is integer, and we're going to say attack roll. And then here we could say printf monster died, like that. I think that's pretty cool. And we'll do system pause here. System pause. All right, system pause. So that will print out that the monster died and pause the game. And then we'll do a bunch of level ups and stuff. And if he didn't die, else, and let's also return, because if the monster died, we're done. Actually, if the monster died, we need to call set tile, right? Because we need to make the tile a dot. So we're going to set tile target x target y to a dot if the monster died. Wonderful. And then return. Semicolon. All right. And yes, that's correct. Else, we're going to say now the monster fights. And we don't need an else because this is going to return if this happens. So now the monster's going to fight. So attack roll equals monster fight. Monster turn. Attack roll equals enemies I, which is the current enemy that we're attacking, dot attack. And then we need to say the same thing right here except with the player. So we're going to need to copy paste some functions. Attack result equals player dot take damage. Dot take damage attack roll. So let's go ahead and copy that function from enemy right here, take damage, and put that in player. Put that at the bottom. Int player take damage. And for the player, we don't care about his experience that he returns, so we're just going to return 1 if he died and 0 if he didn't die. So let's also copy it up here. Void player take damage, and let's actually put it below the attack. That makes more sense. Like that. All right, so that will take damage for the player. And then it will return 1 if he died. And that's that. That's simple as that. So if he died, we need to check that. And let's go to the level and say, okay, here we go. If attack result is not equal to 0, blah, blah. We'll just copy this exact thing. Then we're going to say, you died. And let's also set the tile to a dot. So let's actually, each time we do a battle thing, if he dies, let's print out the level too. So let's set the tile before we print out monster died, and we'll call print level to kind of refresh it. We just call print like that. And we'll do the same thing here. So we'll print you died. And let's actually put like an X for like dead body or something. So printf you died, system pause. We don't need to add experience. Instead, what we're going to do is just call what we could do is return. We need to tell the game that we're done. So let's just call exit. That's just going to exit the game like that. Now what you could do is make battle monster return a bool that's like true if the player died, and you could basically return true up through all the function calls. But I'm just going to do this because it's really simple and I don't really care about you starting over. If you want to start over, you'll just restart the game. At least in my simple little game that takes like an hour to make. It's probably a little longer than an hour now. Alright, so that's that. We should be able to fight monsters now. Let's see how it works out. And right now we're not printing out the stats or anything. Like we don't know how strong the monsters are that we're fighting. We don't know how many lives we have or anything like that, or how much health we have. Oh, I didn't save the level. Gotta hit save. There we go. Alright, so here's our game. You can see me at the top left here. And oops, I tried to enter an arrow key. Press any key to continue. Alright, so I'm going to go fight this snake. And it doesn't seem to be working. I'm not getting any input. So I can move around the snake and bump into him, but it's not battling. So let's see if the battle function is actually getting called. We have a bug here. So one thing we can do to check if a function is getting called is while the game is still running, we put what's called a breakpoint in. So I'm going to put a breakpoint by clicking on the line, on one of these lines. Now I'm going to try to bump into the snake again. And it does break. So we're definitely running into the enemy. I know what's wrong. We called enemies.getPosition, but we never set the position of the enemy. It's equal to an uninitialized variable. So what we need to do is, where is it? In load, we need to set the position of the enemy. So what we can actually do is, since that we know whenever we call pushback, we know that the last enemy is, or the enemy at the back of the array is the current enemy. We can just say enemies.back, which is the last element, dot set position. And we're going to set it to, what was it? J, comma, I, like that. And we'll do that for all of these. All of the enemies. That will set the position of the enemy, because that's pretty important. There we go. So now let's try again. And actually, we should probably put in some more print statements. Player attacked monster, good. And then we need to say, right here, we'll say monster. And we should actually print out its name. So %s attacked player. And I spelled monster wrong. Enemy. Attacked %s. So let's actually get the name of the enemy here. String enemy name. And we'll say enemy name equals enemies I dot get name. So let's write that get name function. Getters string get name return name. Simple as that. We'll go back to level. So now we have the name of the enemy, so we can use it in here. So since we have two variables in here, we need two variables over here. The first one is %s, which is the enemy name, and since we're using printf, we have to say cster. Oops, cster. And we'll do the same thing down here for enemy attacked player with a roll of attack roll, like that. And there we go. That should make things much more interesting. So let's go ahead and run it. Now we should be able to see us fighting the enemy. So let's zoom in, and I'm going to go try to kill this freaking snake. Ah! I killed it. It didn't seem to print out, but maybe that's because it was, Yep, you can definitely fight the snake, and it says monster died. Let's see if I can die. Let's go find the snake and fight him. Monster died. Let's go get killed by the ogre. The ogre... Ah! I died. There we go. And actually, it looked like it changed target X. We actually want to change the player's X coordinates. So let's get the player's coordinates. Int player X, int player Y. And let's say player dot get position, player X, player Y, like that. So that'll get the player coordinates, and we can use those, because right now it made the enemy look like it died, but actually we want to turn the player X, the player into an X. Okay, so that's that. We can now battle the monsters. It didn't actually, let's see, where are we calling print? Ah, we never call system pause, so this all just happens. So I think we should call system pause at the end of every battle phase. So system pause. That should make things more interesting. And it looked like we never leveled up. But I guess that's because the monster's experience aren't high enough. So let's balance this a little bit better. Let's say the snake gives you 50 experience, which should be 1 level. Goblin gives you 150. Ogre gives you 500. Dragon gives you 2,000. That's fine. Bandit gives you 300, sure, or 250. That's a lot of levels. And let's lower the defense of some of these monsters. Well, I guess we're going to be doing a lot of leveling up, so I guess this is fine. We're probably going to get really OP really fast. So let's make the ogre do 40 attack and have 40 defense. Alright, so that should be kind of interesting. Actually 20 attack, because our player never regenerates any health. So maybe y'all could add some code that makes the player slowly regenerate health. And also it might be cool to see over here on the right side of the board, we have plenty of space. What you could do is print out information about the player. I'm not going to take the time to do that right now, but if you wanted to, you could totally just print out like player stats and then use the printf with the formatting to print out his health and his attack and things like that, and maybe even his inventory if you're going that far. So now let's go see if we can battle the snake and get some print statements. I didn't do new lines. Alright, let's try that again. Go down here to the bottom, to the battle, and /n, and /n. Let's put an extra slash in at the beginning. Now let's try again. Alright, zoom in. There we go. Player attacked snake with a roll of 9. Snake attacked player with a roll of 2. And next, it was a roll of 2, 2. Monster died. We didn't level up. Doesn't look like. Monster died. Leveled up. Alright, we got a level, so that works. My print statements are absolutely horrible. So I'll be sure to clean up my print statements a little bit whenever I make this public on the paste bin for sure. And I might even pretty it up. See how it does that really annoying thing where it like moves the command prompt because it's doing system pause. That may be a little bit unavoidable, but I'll try to fix that up too whenever I put this online. And are we gonna die yet? We're probably about to die. Well, our player's doing a lot of damage. See, we're doing 40 damage now, and we're only taking 2 damage because we are like level 10 probably or something. Because this is such a we gotta die. Come on. We killed the monster and we leveled up like 8 times. This is so bad. But you will do better for sure. Here we go, here we go, here we go. We're gonna get killed so fast. And we died immediately when we tried to fight the dragon. Alright, so the last thing we should do, should only take us about 20 or 30 minutes, hopefully less, is make it so the monsters move around and like amble around. And if you really wanted to, you can make the monsters battle each other. You could give them AI and make them move toward enemies, and you could be really cool with this kind of stuff. But let's go ahead and do that. When we actually have the graphics tutorials going on, you could probably come back and revisit this game and make it much better and make it so that you actually use colored ASCII graphics, or maybe even using actual textured tiles. So we have our level. Let's make a new function, and it's going to be void update monsters. So this will update all the monsters. And let's also pass in the player from the main function so that the monsters can attack the player. So update monsters with the player, and we're going to go to the definition of move player and put it right below that. Alright, and I'll add lots of comments to all these before I put it online, don't worry. So this is going to be a level function. Alright, so all we do is loop through each monster and update him. So for int I equals 0, I is less than monsters or enemies. God, this is enemies. Update enemies. I'm never going to stop calling them monsters. Update enemies. Alright, for I is less than enemies dot size, I plus plus, and we're going to update each enemy. Now what we can do is call a function an enemy that gets his move command. We can make him generate a random move command, so we can actually give some basic AI. So let's make a function that returns a char, gets AI move command. Alright, and what we're going to do is we're going to pass in the player, so we could see maybe we want to walk towards the player. And we're also going to just perhaps do some random chance. So let's return a char. So the enemy is going to press W, S, A, or D, depending on which direction he wants to go. Or maybe he'll press like a dot if he doesn't want to move anywhere. We'll give him some special characters. So char get uh, get move. And we're going to pass in a player. So we're going to pass in player, ampersand player. So we need to include player up here. Include player.h, like that. Cool. So he is going to do get move. And actually, what we could do is, instead of making this just get the move, actually, yeah, we'll do this. We'll just make it get the move. So instead of actually passing in the player, we can avoid including player.h by just passing in the player position. So we'll say int player x, int player y. That's a much easier way to do it because he's not going to be doing anything to the player. He's just going to be trying to move towards the player, perhaps. So let's copy this and put it below take damage, like here. And I'm going to pause the video for just a second because it's been a long time and I need a bathroom break. And I'm back, sorry about that. All right, so we need to get some enemy AI. So first, let's check and see how far the player is and try to move towards the player. So if, let's actually make a distance variable, and we're gonna get the distance in tiles. So int distance from player. And we're gonna say, we can just call it distance. We know what it means. We don't need a variable that long. So distance equals, we're going to say player x minus x. And let's take this and do the absolute value. So we're going to say, actually, yeah. We're going to say absolute value of this. So if the player is to the left of our current x position, then this is going to be a negative number because it's going to be a small number minus a big number. So we're just going to take the absolute value of the negative number in that case, and it'll be a positive number. We always want the distance to be positive. So we're going to take the x distance plus the y distance. So absolute value player y minus y. So that'll get the x distance and the y distance and add them together. And we're going to say if distance is less than 5. Now, instead of just using this random variable 5, we could have a specific property of enemy like attack range. For instance, a snake might only attack you if you're standing right next to it, but a dragon might attack you if you're within 10 blocks. So the distance variable right here will help determine how far, or sorry, this 5 right here could be a variable like attack range. That will determine how far the monster should go to attack. But we're just going to say 5 because we'll say less than or equal to 5. So if that's true, we're just going to move towards the player. So what we need to do is say, okay, which direction should we go? Should we go in the x direction or the y direction? Well, it depends which one is bigger, okay, or which one is smaller. So let's actually make some new variables so we don't have to keep calling this all the time. We're going to say int dx and int dy. And dx and dy are the difference in x and the difference in y. So for the difference in x, let's actually say x minus player. That's typically what you do. You typically say this object minus the other object that we want to get the distance from. And y minus player y, and I'm not sure why I wrote it here, because we're going to say dx equals this, equals the x distance, and dy equals the y distance, like that. And then we're going to say, in here we're going to say just dx and dy. And actually, we can even store this so we don't have to call absolute value multiple times. See, we're building good programming practice. Absolute value is a little bit of a slow function. So since we want to use absolute value later, we can just store a dx, which stands for absolute value dx. A dx equals this, and a dy equals this. A dy. All right, so now we have that. So if a dx is less than a dy, so if he is closer in the x direction than the y direction, then we're going to be moving along the x-axis. Okay, so moving along x-axis. And otherwise, if they're the same or if y is greater, we're going to move along the y-axis. Move along y-axis. And we want to move towards the player. So if we're going in the x direction, we're going to say if dx dx is greater than 0. Now, if dx is greater than 0, that means we are to the right of the player. So we're going to say move left. So we're going to return, what's the command for moving left? It's A. So we're going to return A. Else, he's to the right of the player, so we're going to return D. And we're going to basically just copy this for y and use dy. So if dy is greater than 0, that means he is above us because, remember, negative y goes up. So we're going to return w if he's above us and s if he's below us. So this is going to move us towards the player. Now, if we get to here, down here, that means the distance wasn't less than 5. So we're just going to move in a random direction. So let's make our random generator at the top. So we're going to say static default random engine, and we're going to initialize it with time null, like that. And did we ever include ctime? Yes, we did. I think we've already done this. Oh, I always forget to name it. And we're going to name it rand engine. All right, and then we need a distribution. We're going to say uniform int distribution, and we're going to just generate a number between 0 and like 4, or 0 and 5, and that'll determine how he moves. So we make our distribution move roll, and we'll generate it between 0 and, how about 6? That sounds good. So let's generate a random move. So int random move equals move roll with random engine, like that. So that's a random number between 0 and 6. Random engine, there we go. That's a random number between 0 and 6. So let's do a switch statement to process that. So switch random move, like that. Case 0 will return A. And since we have return, we don't need a break because it's going to quit out of this anyways. Case 1, we're going to return W. Case 2, return S. Case 3, return D. And default, so everything else, we're going to return a dot, which means don't move, and we'll process that accordingly. So this is going to give us a 4 in 6 chance of moving and a 2 in 6 chance of not moving, I believe. And actually, a 4 in 7 chance of moving and a 3 in 7 chance of not moving. Let's increase the chance of not moving. So I'm going to, actually, no, I like them to move around a lot. That'll be cool. All right, so this is our AI. It's going to return all this stuff, and this will return if he doesn't move. So where do we call this? We call it in level. So we're going to say, let's get char AI move, and AI move equals enemies I dot get move. There we go. So that'll get the direction. So now what we're going to do is basically do the same thing we did for the player up here, except we know what it's returning, so we don't have to assume he might type capital W for some reason. We don't have to do that because we know it's doing lowercase numbers, or lowercase letters, sorry. And instead of switch input, it's switch AI move. And we need to pass in the player X and Y, that's right. So we need to make player X and Y, int player X, int player Y, player dot get position, player X, player Y, like that. So that'll get his position, and we'll pass it in here so that it knows where to go, which direction to walk towards. All right, so right now this is processing player move. That's not what we want to do. Now there isn't going to be a default. It's just going to be case dot. Actually, we just don't do anything if he enters a dot. So we just ignore it, and we just move on to the next AI. So we could have returned anything as long as it wasn't WS, A, or D. All right, so I guess we should write a process monster move now, which is going to be really similar to process player move. So let's write that, and we're going to say void process monster move. And we're going to pass in the player, like we always do. And we also need to pass in which monster is doing the moving. And I just realized we have a bug, but I'll come back to that. So what we could do is we don't want to pass a copy of the monster, and we also don't want to just pass a reference to the monster. What I think we should do is we should pass the index of the monster, which is its position in the vector, so we can remove it later, which we actually haven't been doing. We actually do have a bug, but it's not a bug that's going to hurt anything. At least it shouldn't hurt anything. Actually, it probably will when we do monster movement, so we definitely need to fix that bug. So we're going to pass in int monster, oh my god, int enemy index, and this is process enemy move. You know what? I don't even care. I don't even care, because this is called battle monster. Oh my gosh. I'll fix this in the paste bin. So process enemy move, int enemy index, and we're going to have target X and target Y, just like before. Actually, we don't even need target X and target Y, do we? Actually, we do. We do need it. Target X and target Y, like that. All right, so that's going to be our enemy move right here. And where is that? We didn't make it. Here's process player move. So here's void process enemy move or lowercase process enemy move. We're almost done, guys, I promise. This is the longest one we've done yet. But it's not exactly easy to make a RPG game in an hour. We're doing the best we can. Alright, so process enemy move will do basically the same thing the player does. Now, one thing we haven't done is we need to be able to remove enemies from our list. And where do we actually do that? That's here, where a monster should die. We should remove him from the actual enemy's vector. Now to do that, what we could do is do the swap thing, where we swap with the end. But in this case, we care about the order. Now, the reason we care about the order is because let's open up Paint here. Oh, sorry, this is some high fidelity stuff. I think I can get us a blank slate like that. So let's say we have here's our enemies, right? Let's say we have 3 enemies, all right? And we have A, B, and C. Now, whenever we process our enemy moves, remember we loop through from left to right like this. We're going A to B to C, and we're going to process them one at a time. Now, if we get to B and B battles the player and B dies, then we swap in with C and it works. So everything is fine. So I am not making any sense. Ignore me. It is late at night. I haven't eaten dinner. That is my excuse. So we actually don't have an issue. We can go ahead and just remove the monster. So when the monster dies, what we're going to do is say, let's say enemies I equals enemies.back. Remember, this is the secret to removing an element from an array really fast. And then enemies.pop back. That will remove an element from an array. So remove the enemy. Now, the only thing is, and maybe this is what I was trying to tell you, the only thing is when we're here, right, I equals 1, because I equals 0 here and I equals 1 here. If B dies, what's going to happen is we're going to kill B, we're going to copy C and put him here, right? And we're going to call pop back, which gets rid of this. But then we're going to call I++, so then our I is going to be here and we're going to end, and C never got to move. So what we have to do is whenever we call pop back, what we could just do is do I minus minus. So that will actually subtract 1 from our I counter. And then at the bottom here, it'll say I++, and we'll basically process the same enemy. But the enemy is now equal to enemies.back. So we're just going to basically process C in the next turn. And we basically just have to say I minus minus, or we're going to skip that enemy. Okay, so now we can do process enemy move. Let's copy this. And player got get position. Good, good, good. Move tile equals get tile. Good, good, good. So what we're going to do is, if it's a dot, then we can move the enemy. So we're going to say underscore enemies enemy index, like this. Because remember, enemy index is the current enemy, in enemies. It's the index of the current enemy. We're going to set his position, and then we're going to set tile of, we need an enemy x, so let's have int enemy x, int enemy y, like that, and enemy dot, whoops, enemies, enemy index dot get position, enemy x, enemy y. There we go. That'll get our position so we can use it. And so there we go. Set tile enemy x, enemy y, and set tile target, and not equal to the @ sign, but equal to the enemy's symbol. So we're going to say enemies I dot get tile, which we haven't written, so let's write that real fast. Getters char get tile, return tile. There we go. Perfect. All right, so now our AI moves us around. It works. Now it's not going to battle us because we haven't written that yet. So let's go ahead, and we obviously don't want the monster to battle the monster. So for default, let's just do nothing right now. That should be good. So if we run into a wall or if we run into another monster, he just won't move. All right, let's run it and see what happens. We get build errors. That's what happens. Our build errors are, we have 4. I is undefined. It should be enemy index. And looks like all of these functions happened in the same spot. That tends to happen. Or all these errors happen in the same spot. All right. Now let's see if our monsters move around. Ah, I know why they don't, because we never called the function. We have to call that AI function, update enemies. And we'll call that from game system in our game loop. So we're going to call player move, and then we're going to call update enemies. So we're going to say level dot update enemies, like that. All right, now let's run it. Now our AI is working. Oh, and we have to pass the player because the enemies need something to target. All right, let's run. All right, zoom in. All right, let's see if the enemies move around. And it looks like they don't move around at all. Also, my player's movement is all messed up. I think, oh, the enemies are moving my player, aren't they? The enemies are passing movement commands to my player. Bugs are neat. And that happened because we called process player move. We want to call process enemy move. So the enemies are moving me around against my will. Processed enemy move. Like that. And let's see, the target X, the target Y, and also the enemy index, which is just I. So we also need to add the I parameter right here. Pretty simple. All right, so now the enemies aren't going to move me around. They're going to move themselves around, which is actually a pretty funny bug. Let's zoom in. All right, and I really think it's going to work this time. It didn't work because they moved to the player position, didn't they? They totally did. So they all teleported to the player, another bug, because we used player X. I just copy-pasted this without doing anything, didn't I? And update enemies. Did we ever get player position or get enemy position? We did not. So int enemy position, enemy X, and int enemy Y. So we need to do enemies I dot get position because we don't want them to teleport to the player. We want to move them next door by 1 tile. Y. Perfect. And this time I really think it's going to work, and every time I say that I'm typically wrong. I've got about a 30% success rate, so let's see what happens. Shouldn't have any more bugs. Now the enemies should move around. There we go. Look, they're moving around and they're doing all their stuff. They're being smart. All right, let's see if this snake will chase us. Looks like I got the directions wrong. So it's chasing me in the X direction, and it's never following me in the Y direction. Ah, because it needs to move. I see why. So the issue is we said move along the axis that is closer. when really we should be moving along the axis that is further. When you were paying attention when I was doing that, the snake was way far below me, so he had a really far y distance, but his x distance was equal to mine. So he actually should have been moving along the y direction, not the x direction. That's a really easy fix. We just changed the less than sign to a greater than sign. Actually, the greater than sign to a less than sign. All right, this time let's see if the snake will chase us. And he's going in the opposite direction now. So somehow I got these backwards. So this should be D and A and S and W. All right, so we are now like, what, 1 for 5? Still hasn't worked yet. All right, moment of truth. What is he doing? What is it doing? It's not working. That S is kind of following me. It's following me in the X direction, but it's not moving along the Y direction, which is a bit obnoxious. So I might pause the video so you don't have to sit here and watch me fix the bug. In fact, I'm going to do that. Okay, pretty much immediately after pausing it, I realized how much of a fool I am. The reason switching that messed it up is because I changed the wrong less than sign. I did it without even reading. This is the sign we should change. And that explains why everything flipped direction as well. So we were right the first time. We just did something stupid. And it is now chasing me. There we go. So see, he's walking right up next to me, and he should be attacking me right now. And let's get a big train of people to follow us. Oh god, they're all chasing me. They're all chasing me. Oh, we lost 2 of them. They must have gotten stuck on a wall. And the dragon killed me. Alright, cool. So now the last thing we need to do is make it so that they actually fight the player. And to do that, we just need to modify update, or what is it, move enemy? Process enemy move. So we just need, we can put the wall in the default here. Case player. So if they ran into the player, then they need to battle the player. So we're just going to call battle monster again. So we'll say the player gets to attack first, even though the monster should attack first, just to make this thing end quicker. So we'll call battle monster with the player, and the target X and target Y is going to be enemy X, and enemy Y. And there we have it, our game, our game that took forever to make, but you learned it line by line, is done. So and by done, I mean you need to go work on it and make it even cooler. Alright, so player attacked snake. Even though really the snake should be attacking the player, snake attack player. I'm not attacking him, I'm just like moving against the wall and he's attacking me. So there it goes, it works. And as you can see, these goblins over here are trying to chase me. And they're kind of bumping into each other and stuff, and they're trying to chase me through the wall. So it would be really interesting if you could see if you can figure out a way to make them not try to walk through walls. And actually, you could even make it to where the player has a certain view radius. So right now I can see the freaking dragon over here. That doesn't really make sense. What you could do is make it to where it only prints out tiles that are within a certain view radius. And maybe if you Google something called the breadth first search algorithm, if you're really interested in doing some really crazy stuff, you could use the breadth first search algorithm to determine like a line of sight or something like that. Or you could do a lot of really cool stuff. Just do whatever you want. You've got the basic program now. You understand how to do these things. Let me zoom out. And you really should just try to enhance this. I'll be sure to make comments on this and put it on Pastebin. If you guys make a really cool game, definitely make a video of it explaining some of your code, kind of go through your code, definitely post your code online, and make a video response. And what I'm going to be doing for all these challenge videos is if you make a video response, I will put your video response in the description, and I'll also rate you. I'll have like a top 10 or a top 100 videos, however, depending on how many people make response videos. And the reason, in order for you to get on that list, the reason I want you to make a video is because I want you to practice explaining to somebody else and to explain to other people. And that's what really makes you good at the code. If you can explain your code to someone else, then that means you understand your code, and it's going to help you understand your code. So definitely do that. Thanks for sticking with me. We went through this thing line by line, and we've got a few hundred lines here. This isn't a tiny program, but there's a lot more room for improvement. You could improve the level system. You could add an item shop. You could do that. The maximum view distance thing I was talking about. You could do all sorts of really cool stuff, or you can save this and wait until we learn about graphics, and you could make it into a graphical game. However, you might as well just work on it now, and it's pretty easy to just upgrade the graphics later. You can use your existing code and kind of pop it into a system with graphics. So thanks for watching, guys. Hopefully this wasn't too confusing. You should be able to rewatch any section of this if it specifically confused you. If you're still confused about anything I did, just comment in the description and I will show you what I meant, what I was trying to do, or I will provide you a better example of what you could do to accomplish what I've been trying to do. So thanks very much, guys. We've got only one more challenge video, and then I think we're going to move on to graphics. So stay tuned for a few more tutorials. We're going to learn about pointers and lots of really cool stuff. Thanks, guys.